section 3.1, and we're going to split that into 2 days. So this is part A. So our objective is the student be able to solve quadratics by using square roots. We're just going to do one thing today. And to solve quadratic equations by using square roots, you have 3 basic steps. The first one is to isolate the part of the equation that is squared. So that means whatever you have squared, you're going to get that by itself. Then you're going to take the square root of both sides. And then the last thing you're going to do is simplify the radical. Now, you should have done this in Algebra 1 or Geometry, but probably need some review here. So we have 3 basic things that have to happen to make sure a radical is simplified. The first one is that there's no perfect squares under a radical. So that would be, as an example, if I had the square root of 50. So what you want to do is break down that 50 into its prime factors. So a lot of you have worked with factor trees before, so 5 times 10. And then I can break the 10 into 2 times 5. So what we're looking for is pairs, because I can take the square root of that. So I have 2 5s, and if I have 2 of them, I can pull that 5 out front. And then what I don't have 2 of, stay inside. So square root of 50 would simplify into 5 square root of 2. The other thing you can do is, if you know your prime numbers, or your perfect squares, you can just break that into 25 times 2. And the square root of 25, if I can take the square root of it, it comes out front. And if I can't take the square root of it, it stays inside. So whatever works easier for you on taking and simplifying those. And you'll see those as we go through the problems. The second thing is we can't leave a fraction under a radical sign. It says no fractions under a radical sign. So if I have the square root of 2/5, I can't leave it that way. I can't leave a fraction inside there. Now this part's easy to take care of. All you do is you split it up into 2 parts. So you break it into the square root of 2 over the square root of 5. The problem with doing that is you violate rule number 3, which says no radicals in the denominator. So I can't leave a square root in the denominator. So what I do is I break this up. And then what I want to do is multiply this by the square root of 5. Because the square root of 5 times the square root of 5 is 5. The problem is, the only thing I can multiply to a fraction, or to any number, and not change it is 1. And so I multiply it by the square root of 5 over the square root of 5. And so we get square root of 2 times the square root of 5 is the square root of 10. And so the square root of 10 over 5 would be our answer. So I'm going to probably come up with a worksheet to help us review this so we get a little bit more practice at it. But you'll see some more as we go through the problems. So, these first examples. 4x squared minus 31 equals 49. So if we go back to our steps, the first step is to isolate part of the equation that is squared. So the only part that's squared is this x. So I have to isolate that, which means get that x squared by itself. So we follow our steps. We add 31 to both sides. And so we get 4x squared equals 80. Then I have to get rid of the 4. So I divide by 4. And that gives us x squared equals 20. Then, once I have it by itself, so we've isolated the x squared. So now I can go to step 2. It says take the square root of both sides. So now what I do is, I'm going to take the square root of this side and the square root of this side. The square root of x squared is x. And then when you take the square root of something, remember, square root is what times itself gives you that number. And like if we have the square root of 25, it's 5, but it could also be negative 5, because negative 5 times negative 5 is positive 25. So all we do is simply put plus or minus the square root of 20. But then we have to make sure we simplify the radical. So in this case, we're looking for things that go into 20 that I can take the square root of. So again, you can simply take that 20 and break it down. So that'd be 2 times 10, and then 2 times 5. And so I have 2 2's, And so a 2 comes out front, and I only have one 5, so it stays inside. The other way to do that, remember, is I can just say, oh, something I take the square root of that goes into 20 is 4. 4 times 5. The square root of 4 is 2, so it comes out front. And then the square root of 5 I can't do, so it stays inside. Whichever way works better for you. With smaller ones, I like to do it this way. If you get into complicated ones, it kind of works nice to break it down. So let's look at this next one. So now we have the x squared again, so we have to get this x squared by itself. So we're going to start by subtracting 9. And so that gives me 3x squared equals negative 9. And then I'm going to divide by 3. And so I get x squared equals a negative 3. And then I'm going to take the square root of both sides. And we get x is equal to, but now we run into a problem because we have the square root of a negative number. So the square root of a negative number, again, square root is you multiply it by itself to get that. Well, if you multiply a positive times a positive, you get a positive. And if you multiply a negative times a negative, you get a positive. So there's no way to get the square root of negative 3. So what we're going to do for today on these is we're going to put no real solutions. Later on in the year, we'll learn how to find this answer, and we'll work with what's called imaginary solutions, and we'll be able to find that square root of negative 3 will be able to do that. So for the third one, again, we have to isolate the part that's squared. Now in this case, we have x plus 3 is squared, so I'm going to isolate that whole thing, and it's multiplied by 2/5. So to get rid of a fraction, it's multiplied so you divide, but dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to multiply both sides by 5/2. And so on this side, 5/2 times 2/5. You can multiply straight across the top, straight across the bottom, and get 10 over 10, which is 1. Or you can simply say, oh, the 5's cancels and the 2's cancel, so that gives you 1. But we end up with x plus 3 squared equals, now remember there's no number in the bottom, so it's a 1, so that would be 25 halves. So now we're going to take the square root of both sides. So we're going to take the square root of both sides, and we get the square root and the squared cancels, so we get x plus 3 equals plus or minus the square root of 25 halves. Now I'm going to go ahead, you could simplify this now, I'm going to wait. We're going to go ahead and move the 3 to the other side, so I'm going to subtract 3. And so I get x equals plus or minus, sorry about that, negative 3 plus or minus the square root of 25 halves. So we can't leave it like this. The nice thing is I can break that up into the square root of 25 over 2, the square root of 2. The square root of 25 we can do, so we get 5 over square root of 2. So now remember, all you do is you multiply by this denominator. When we're square roots, we can do that. Square root of 2, square root of 2. So I end up getting x equals negative 3 plus or minus 5 times the square root of 2, and square root of 2 times the square root of 2 is 2. Now this minus 3, it doesn't make any difference. I normally put it in front, but you could put plus or minus 5 square root of 2 over 2, and then put minus 3. It really doesn't make any difference. So hopefully these helped. What I'd like you to do, these are the MPs out of the book here. I just wrote them up here so you can see them, wouldn't have to go to the book. But what I'd like you to do is go ahead and pause the video here, try these 3, and then come back and see how you did. So let's take a look at these. Again, you should have isolated the x squared first. So I'm going to go ahead and subtract 14. So we get 2/3 x squared equals 6. Then I'm going to get rid of this 2/3 by multiplying by the reciprocal 3/2. So over here the 3's cancel and the 2's cancel, so we get x squared equals, again you can go 6 times 3 is 18 divided by 2, which is 9, or you can say 2 goes into 2 once, and 2 goes into 6 3 times, and 3 times 3 is 9. Take the square root of both sides. So x equals plus or minus 3. Alright? Again, the nice thing is you can check these. You can plug it in. 3 squared is 9. 2/3 times 9 would be 6. 6 plus 4 is 20. And if you did a -3, and -3 squared would still give you 9, so it checks. So if you did this one correctly, again, the first thing we would do is subtract 1. So we get -2x squared equals -7. Divide by -2. So we get x squared equals 2 negatives is a positive, 7/2. Take the square root of both sides. So x equals plus or minus the square root of 7/2. But again, we can't leave it like this. So we break it into the square root of 7 over the square root of 2. And then we multiply by the square root of 2 over the square root of 2. And so we get x equals the square root of 14 over 2. You can't simplify this because you can't take a square root, a number outside of square root to a number inside the square root. So we'd be done. And this would be, don't forget the plus or minus. Last one. So again, this whole thing is squared. So the first thing I'm going to do is divide by 2 and get x minus 4 squared equals -5/2. And then I'm going to take the square root of both sides, but as soon as I see this, I can't take the square root of the negative number, so I'm going to put no real solutions. So hopefully you found those fairly easy to do. The simplifying of the radicals might be the hardest thing. It's going to be a short assignment. There's going to be 8 problems. But again, we'll probably have a worksheet on just simplifying radicals to make sure we're okay on that. So that's it.